Hey, hi everyone. Good evening. Hope you are doing well. Welcome to our sessions, a series of sessions on pharma analytics. Hope you have enjoyed the series of sessions that have been conducted till now. Today's session, we will be discussing about a new topic called survival analytics, which is very, I should say, ideal topic specifically for the pharma sector. When we talk about clinical trials, when we talk about trying to see the effect of medicines, right, comparing the medicines effect on different patients, different segments of patients based on age group or gender, the kind of locations maybe, right? The effect of all these medicines will be different, right? So we want to try and study that. Now, as part of the series of sessions till now, you people have understood how analytics helps the pharma sector, right? Pharma industry. We will be talking about the survival analytics, which is a little different from whatever you have learned till now. Probably you have got exposed to various techniques under data mining or machine learning for pharma's industry. You probably have looked at multiple use cases. You have learned about unsupervised learning techniques, which will allow you to segment the users, segment the items, or various other descriptive analytics-based strategies. As part of supervised learning, you have learned how to do predictions. So you might have got exposed to classification models. You have got exposed to regression-based models. And you also have learned about the evaluation metrics or evaluation techniques to identify how the model is performing in these respective right, cases. This falls under predictive analytics case, whereas unsupervised falls under descriptive analytics module. We are trying to understand the data using some quantifying techniques for probably report generations and identifying some kind of patterns, etc. That would be your descriptive analytics module. If you want to upfront try and estimate a value that you are not familiar with, given the bunch of conditions, then this is called as predictive analytics models. Now, for example, you might want to know if a cancer patient will survive or not. If you want to identify this, if you want to predict this, you probably will be using a classification model. This will tell us whether the patient would survive or not. And 1 and 0, you might want to define according to your comfort factor. You might say death is 1, survival is 0, right? Vice versa. You can define these binary cases. Now, to do this, there are many classification models and number of different things that you can do. You probably have learned about something called as decision trees. A tree-based algorithm which generates rules to identify what conditions are affecting your outcome. But this may not solve the purpose. This may not solve the case in a lot of scenarios. The important point that you might want to know is how much duration will the patient survive? For that matter, if you want to do a clinical trial, you want to understand if you're giving a specific combination of drug, composition of a drug for, let's say, XYZ problem. right? XYZ disease, you can say. Then what would be the survival duration, right? How long would the patient survive? That's an important point that you might want to learn. But how do you get this duration? Right? That is the topic of today's lecture. Survival analytics is the module which speaks about analyzing the duration of the subject before the event happens. Now, the event in this example might be cancer. Whether the patient would die due to cancer or survive. If the patient is surviving, how long would the patient survive given the conditions? Probably a specific drug or a specific treatment, you can say. For cancer, it is a treatment, right? So this is the duration analysis that we are trying to do. Now, this would probably allow doctors or the medical practitioners to come up with the best solution for a given scenario. Ultimately, we want to ensure that the patient survives for a longer duration. He's alive for longer duration as much as possible, right? So the survival analytics is all about understanding the duration before the event happens. So welcome to the session. My name is Sharath. I'm your faculty. And thanks to my connections, I was able to work with oncology department specialists, professors, the doctors who come from oncology department. I did had my share to work on TNBC cases. TNBC is triple negative breast cancer. And I was fortunate to work with this specific, peculiar or very rare case of cancer in women. The subject was to analyze how long would patients survive with TNBC. There were various factors that we wanted to analyze on what kind of effect would these factors have on patients. For example, the age is one of the factor. The stage of the cancer was one of the factor. The kind of treatment that the patient was receiving, that was another factor. So given these conditions, in which scenario the patient has high survival chance? That was one of the case study that we have worked on. Along with this, we also had relapse. Yep. Relapse in cancer patients. So you have given the treatment to the patients. After some days, after the complete cure based on the treatments, once the doctor declares that the patient has completely cured, after a few days, few months, or few years, whatever the duration is, the cancer reappears in that particular patient. So what are the chances that the patient might see the cancer reappear, relapse? In what conditions the cancer might relapse, right? If it is relapsing, what is the duration of that right, relapse? When, after how many days or how many months the cancer would relapse? This was a very interesting case study that I had worked on. I'll be showing the reports. I'll not share the data. Of course, I'll show you the mocked up data. And then I'll show you the work that we have done. And post that, we will talk about another use case, which basically talks about surviving of the patients based on the treatment of a clinical trial. Now, before I go ahead and talk about the use case, the NBC use case, we would want to understand that the survival analysis is all about duration of the subject, right? We are trying to analyze the duration before the event happens. Now you have to define what is the event. And in order to analyze this duration in survival analytics, we will be using something called as hazard functions. Cumulative hazard functions. If I have to put it in a very simple terminologies, I would say the chance, which is nothing but probability, right? Primary or elementary, I should say primary mathematics if you talk about school mathematics. Probability is what we are trying to understand here, probability functions. Now, in this case, we have non-parametric analysis, parametric analysis or parametric models, and we'll also have semi-parametric models. The survival analysis based on what is that we are trying to analyze, the event that I spoke about. We have different types of variations in survival analytics that we will be approaching or applying. The most popular one, and in our discussion today, we will be speaking about non-parametric analysis, whether the patient survives or dies. So this is an event, right? It is like a discrete value, either 1 or 0. That's it. Only two options, right? So to see the analysis on this particular duration analysis on this particular event, we have to go for non-parametric analysis or non-parametric models. And for non-parametric models, we will have a specific function called Kaplan-Meier survival function. So we will be discussing about this. And these are some of the examples and the definitions. I've not just put the pharma analytics examples, pharma related examples, but I've also tried to bring in different examples so that you people can actually understand how the survival analysis can be implemented in real world also. You might want to correlate things here. So survival analysis is also called as duration analysis, the transition analysis, failure time analysis. If you're talking about the death of a patient because of cancer, you treat that death as a failure. So how long does it take before the patient dies? That is failure time. Or simply you can say time to event. That event could be either 1 or 0. Now what we do is we try to follow up and study each and every subject in that particular data and see from a defined starting point how the events are occurring in all these subjects with respect to time. So starting point will be here, and we will be analyzing the subjects until the end date that we predefine, start and end. This is the duration time. And we are analyzing the subjects in this time. These are some of the examples. If I talk about loans, bank loans, there will be defaulters, right? We know Kingfisher Group, we know Sahara Group. We had right, other groups, organizations or individuals who have defaulted on their bank loans. If you can upfront know on whether a particular organization or a particular lender, individual or an organization, would default on their loans or not, you would probably not give the loan in the first place. Right? That's what your prediction models will help you to achieve. But you don't want to lose the business opportunity as well. There's a risk element, but still there is a business opportunity. So you might want to also understand on, if we give loan, when would be the customer defaulting? So once you can identify the duration before the customer is going to default, Based on this information, you can do some calculations and define how much amount you might want to give for the loan. Generally, banks work this way. Now, if I talk about the patient's scenario, we just now discussed whether the patient would survive or die because of the disease. It could be cancer, it could be any other disease like COVID or whatever that is. Time to retirement or time in finding a new job for college fresh graduates, fresh passed outs. How much duration that these people will need before they find a job? From a HR perspective, employees resign. And if employees resign, there is a huge dent to the organization because the new people who are being onboarded, they needed to be trained, their salary packages would be high, right? And it takes some time before the employees start to performing, right? I mean, they have to be onboarded and then they start performing. Now, how about trying to retain the customer, these employees, right? Now, if HR people can understand upfront on when an employee would resign, then according to that duration, based on that duration, HR people can do some kind of counseling, understand the requirements of the employees and ensure that they stay loyal for longer duration. Beginning of an insurance before their first claim. Time from the beginning of a customership to churning issues of customers' credit card. Right? So there are a number of such examples in real world that you can think about. Now, we cannot use the same techniques that we have discussed till now on this particular data because this data will not have the same distribution or the same spread that regular data has in normal. The data that we are going to deal with will always start with 100% and then it keeps decreasing as the time goes by. So this is not quite normal, right? So we need to try and apply a different logic altogether. And then the another problem that we will have is the censoring in the data. Okay. Now, the survival analysis is basically a technique where we track the subjects from the start date. We track on how the events are happening for each and every element or subject in this particular study. If the event happens, that means you need to stop tracking, right? I mean, say for example, patient died because of the cancer, then that's nothing but event happened. There is a duration. Beyond that, there is no data. Now, there may be cases where we may lose the subjects, and this is called as censored data. Now, our interest is to see how long these people have stayed, right, within the sample or within the study. This duration that we are trying to look at is going to help us to, let's say, pass out a statement saying that so-and-so kind of a treatment will help the patients to survive for a maximum duration in a given disease conditions. Clinical trials, right? So we will be able to pass such statements if you look at the survival of the patients. We also want to look at the hazard rates. Hazard rates are nothing but probability rates, you can see. What is the risk of failure at specific intervals of time? You might want to quantify the values. We will always start from a predefined time, and that's where our analysis also begins, until the duration, which is also predefined. Right? So these are, again, some of the examples that we have discussed. The starting of a customer subscription to churning of a telephone subscriber. For example, you have subscribed for, let's say, Airtel. You have started today, right? 3rd June. You have taken a Airtel subscription. Now, after a few months, let's say you're churning away to competitor. It could be Vodafone, it could be Jio, right? It could be anything. You are churning away to a different telephone subscriber. Now, for Airtel, as an example that I've taken, for Airtel, we losing a customer, right? Business revenue is lost. So why the customer is leaving out, churning out, or something that Airtel would definitely want to know, isn't it? If I can understand the reasons, then addressing those reasons would become our primary concern, so that we don't lose customers. That means we don't lose business, right? The time in employment until attrition, resignation of an employee. You might want to understand the duration, how long the employee would stay. Time from issue of credit card to the first default payment. You have taken credit card, right? For example, a customer has taken a credit card, has used the card, and he did not pay the amount back, the credit back. That means the customer has defaulted, right? After how many months of usage of credit card, the customer might have defaulted, right? You might want to understand that. Time from the current purchase to the next purchase of some product or same product. So the duration that the customer is taking before making next purchase, right? This is also survival time. So on and so forth. Insurance example is also there. Before you make the first claim, how long you have been using the insurance policy, how long you have been the customer for that insurer. Next, we would try and look into the patterns in the data with respect to a specific behavior in the in the subjects in that duration of study. And we also want to identify what are those key points specifically where the rates drastically fall down, right? In which case the values are falling down. You might want to understand the reasons for these falls, right? So we will start comparing the survival curves. We will get survival curves. We will be looking into those curves and try to compare the effects with respect to various factors. It could be based on demographical groups. The customer segmentation does, right? For each customer, there will be a different kind of a behavior. The sales channels could be another factor, right? So on and so forth. So what are the factors which are influencing the event occurrence in the scenario, in the duration? In short, you're trying to do factor analysis, right? This will enable us to do some kind of a predictive analytics as well. And you might want to tune the factors, the values of the factors that are affecting the event. If you know which factors are influencing more, then you'll be addressing those factors, those conditions appropriately, right? And we will be using something called as Kaplan-Meier curves, which is obtained from life tables or actual tables. This would help us to come up with identifying factors and all that. Heavily used, right, resources here, life tables and Kaplan-Meier curves in survival analysis. All right. Carefully understand this topic, censoring topic. And you might also want to see the question, the quiz question, right, that we post on our social media channels. The link to that question is posted in the chat window. You might want to listen carefully to this particular topic that we are now discussing, and then you might want to proceed with answering that question. Next, censoring. Censored is nothing but incomplete data, incomplete observations of the time to event data. Censored means you're hiding something or you're cutting something. Now, in survival analytics, we will have three types of sensors that you might want to understand. And the most important censoring that we are focusing on is right censoring. We will also have left censoring and interval censoring as well. Right censored, left censored, and interval censored. Now, censoring basically means lack of information or lack of data, right? We know that the event did not happen, but we don't have any kind of data for that particular subject. So we are losing that data. This could be because the subject has voluntarily dropped out from the study, right? Or probably there will be some other external factors which are influencing the subject. Let us try and understand this. Okay, let us try and understand this using a simple example. This is a clinical trial, assume. Right? This is a clinical trial that is being performed. Let's say there is a maybe we'll talk about COVID-19 case. Okay. So there are some kind of clinical trials being conducted for verifying the treatment for COVID-19 case. The medical practitioner or the doctor is very popular, very famous, and there's a lot of success rate for that particular doctor, assume, or for the organization which is doing this clinical trial. So they decided to call for volunteers who can try out the medicines, the treatment for COVID. So we're asking COVID patients. Assume that we have 10 subjects who have volunteered for taking part in the study, and the organization started the clinical trial here. So the duration starts at 0, and this is 1 month duration, 2 months duration, so on and so forth. We are studying it for 16 months. The duration is for 16 months. So the granularity of the duration is given on monthly basis. And there are 10 subjects. We can assume that this is, or we calculate it as 100%. All the patients, right? We have all the subjects that we are talking about here who are affected by COVID-19 is 100%. Now, when the study began, all the patients are alive and they're surviving. But let's say when the review happens at the end of the first month, we observe that subject 5 has died, right? Now, we are talking about COVID-19, and the event that we are looking at is the death or complete cure. Okay, either you completely cure the patient or the patient dies because of COVID-19 in this example, assume. So this is our event, an event occurred. So now what we can say is, given this particular treatment for COVID-19 patients, there's 90% chance that the patients will survive for at least 1 month. Right? For sure, we have 90% chance that they will survive for 1 month. Right? So on and so forth. This is how we will do the statements. Now let us try and understand what does censoring means here. Censoring basically means lack of data, as I said. So if you look at this example, subject 2 has dropped out from the study after the 2nd month of the study, overall study duration. So after the patient dropped out, probably got motivated by someone. So patient thought this treatment will not work out. So he dropped out and wanted to try something else. Now, when the patient is not no more involved, right? The patient is not involved in the study, will we be able to get the data for the customer, for that particular patient? No, right? This is called as right censored. Okay. Right side, in the duration, we will not have any information. Did the event occur? No, the event did not occur. The patient voluntarily dropped out, but the patient did not die or completely cure. So lack of information from the end of the second. Now, if you look at this another example, subject 7, right? Subject 7 has died at the end of the 5th month. When we are reviewing, the patient had died. But he died because of some accident, not because of COVID, right? This is the problem that we're trying to address here, COVID-19. So we are saying that the patient had died because of domestic accident. So the event did not happen. The event that we are looking at is the death or the complete cure from COVID-19, right? So patient died, but not because of this issue. So from here onwards, we will lack data from that patient. We'll not have the data, right? This is another example of your right censored. Now we need to see how long these patients are surviving, and we want people to survive the complete duration. This is more important for us, right? So this patient survived for the whole study period. Given this, we will say that so much of percentage of chance is there for the patients to survive the complete duration of study, at least 16 months. So this is about the survival analysis and censoring. So censored data is nothing but lack of data, or data loss happens, or we don't know what is happening. But at the same time, it is called as censored when there is follow-up time still. There is a duration still, right, for your study, but we don't get the data in that duration. Lack of data. So that's called as censored. We will be looking into a small code wherein we will talk about the survival graphs, which speaks about a very generic issue. What is the effect of the treatment for, let's say, inpatients who are joining the, let's say, hospitals, for example. For example, whatever the scenario is, probably COVID-19 case, they are joining the hospital, they're getting admitted into the hospital, they're inpatients, and these people have insurance. If the patients have insurance, then what is the effect of the treatment on those patients? Right? There could be a lot of psychological or financial pressures which can motivate patients to heal better, recover better. So we are trying to see that medical insurance is affecting these patients or not. Right? Very interesting, right? So we may say that how can it affect the patient's treatment, isn't it? We're not talking about drugs, or we're not talking about treatment. We're talking about psychological aspects and financial aspects here. But still, it motivates people to recover faster. And that's what we're trying to understand here. UI equal to 0 is medical insurance, right? Under insurance is 0. That means there is no insurance. Under insurance is equals to 1 means the patients have insurance, right? So we are trying to look at the discharge duration. And this will help us to understand that definitely the medical insurance is giving the patients more relaxed time and their recovery becomes slower. Right? So that's the interesting plot that we are going to look at now. As promised, before we go there, I will show you the survival here. This is the survival analysis for the TNBC cases. This is the overall duration of survival. On x-axis, we will have time. This is on monthly basis, right? And we see that 100% people were there when the clinical trial started. And then after some time, around 30 months, I guess, 35 months, the loss happened, the survival, right? A lot of patients died. But after this time, there's no effect. I mean, people survive. If they survive till 35 months, 33 months, in fact, then there's no issue. They're able to completely survive. This is the output. We are also trying to compare and see what is the effect of the treatment with respect to the cancer stages. We have stage 1A, 2A, 3A, 4, 1C, 2C, 3C. These are different stages. And some examples of different stages we have analyzed. This is with respect to the treatment, the surgery. Complete treatment, complete surgery was done, and there's no loss. Complete treatment has ensured that patients did not die. In fact, optimum surgery also, you can see there's no problem. But with respect to the incomplete surgery or FSO, FSO is another treatment with respect to this cancer treatment, we have seen that there is loss in patients. It did not cure completely. Okay. Then what kind of treatment, what kind of tumor we are looking at? So this is also the survival plot, right? So that's a small example that I wanted to talk about. I'm just showing you at a high level. You cannot show more details because of the data security norms. But yeah, let me talk about this particular case. So this is the spider instance. You might have already familiar. You might have seen this instance. I mean, this UI. This is Spider, which is one of the IDE tools for implementing Python code, which is a way to develop your application, develop your survival analytics code. It's very easy. Python, you might already have seen this. A lot of functions are readily available. We are using those functions to try and implement the cases on our data. So I'll import one such library called pandas, and this will enable us to read the data. This is the survival discharge data. We are looking at the duration. Event is whether the patient has discharged or not. For given this duration at this time, whether the patient has discharged or not. And UI is for that particular patient, whether the patient is under insurance coverage or not. This is the 3 columns data that we have. And we are looking at a sample of 3,343 patients' data. Spell is nothing but the duration. Remember that. Now I'm going to record the spell into a different variable called T. Right? This is the same column, spell column. I'm recording it into this new column. And the durations, first month, second month, third month, right? We are looking at that. For implementing the survival analytics, non-parametric survival analytics model, we will be using this readily available function called Kaplan-Meier fitter. To implement this function, we are going to download it from a package called Lifelines. So from Lifeline, import Kaplan-Meier fitter. We have imported that. And then I'm defining the model as KMF. I'm giving a short name for the function. And I will be using this function for our data set. This T is nothing but the duration. And then here we are talking about the survival discharge event. Event is whether the patient has got discharged or still under treatment. So event is either 1 or 0. So we use this duration and the event to develop the Kaplan-Meier survival plot. This is for all the patients, right? We have not segmented this based on the insurance scenario. And we can see that the patient's discharge summary, probably you can see it's more like a linear, right? When we looked at the scenario, all the patients were admitted into the hospital. But we looked at the discharge summary here, and we understood that these patients were getting discharged. These are the days that we are looking at, how many days it took for these patients to get discharged, the timeline. So for 1 month, we analyzed. Okay. Now this is the survival plot, and we have seen that linear decreases there based on different cases, right? We are looking at the patients going discharged. Next, you look at the UI. UI is the column which speaks about under insurance, whether the patient falls under the insurance category or not. So when I break it up, we have seen that there are 1,848 patients who had insurance coverage. They fall under the insurance coverage category. But we do have 1,495 people who do not have insurance coverage. Now I'm going to do the same survival analysis here, Kaplan-Meier fit, the same function, but I'm doing it only for those patients who have UI is equals to 1, right? They fall under your insurance coverage. So I'm basically segmenting, dividing this data into 2 groups, and I'm doing the analysis first on the patients who had the insurance coverage, and this is what you see. So it's pretty linear. Their insurance coverage is there, so their discharge summary can be seen that it is linear. But when you look at this group where 1,495 people who do not have insurance, right? When you look at their survival curve, you will see that more of the people, right? Majority of the people get discharged quickly. They do not stay, right? 0 means discharged. So these people, because they do not have insurance coverage, they discharge quickly, isn't it? Now, you need to analyze on various other things, of course, but at least we can see this plot and say that people who do not have insurance coverage, they get treated faster, right? Their psychological psychological status, I should say, right? Mental status is very fit. I should not say very fit also, but it motivates them to get cured faster because of the various pressures from a financial aspects that they are getting. So this is, again, you can see how many of these patients who got discharged early are rejoining because of these issues. Whether the treatment was not, if the treatment was not completely given, these patients may see that the disease or whatever the challenge that they were having is reoccurring. Right? So you might also want to dig into those details and then come up with a report. But yeah, survival plot is what we are trying to discuss as part of the scope of this particular session. And survival analytics will allow us to analyze the duration before the event happens. And this will give us this Kaplan-Meier survival plots or survival curves, which will allow us to study the data with factors influence on the event. This concludes the training for today. You have learned survival analytics concept, and we have worked on the 3,343 subjects. And yeah, these are various things that we learned. Survival analysis and how it is different from your prediction models. There are different names given for survival analysis, like time to event analysis, duration analysis, failure time analysis, etc. We have also seen some examples where survival analysis is implemented. We talked about censored data because that is one of the important aspects when you look at the survival analysis data. And we always focus on the right censored aspect. Then we have seen Kaplan-Meier survival function, and we try to understand how to read the survival plot. Hope this helps in analyzing your data in your daily exercises, and wishing you all the luck to fast pace your careers. And with that, I will conclude for the day. And good luck, good evening, and see you all tomorrow. Thank you, friends, and have a healthy life.